Okay, so here on 114, it says calculate the sums of each of the following geometric series for n equals 10 and for n equals 30. What do you notice about the results? And then what makes the difference in the results for the series in parts A and B? So go ahead and copy those down. So we're going to do n equals 10 and n equals 30. I'm just going to copy A for now. That should be n minus 1 in the exponent. I'm not sure why the minus 1 isn't showing up. Okay, so here we want S of 10, and just kind of should write this off to the side. A reminder from what we were working on yesterday and put in our notes, S of n, let that focus, is equal to T of 1 times R to the power of n minus T of 1 all divided by R minus 1. So T of 1 is our first term, R is our multiplier, n is the number of terms. So here for S of 10, T of 1 would be 200. And I'll list kind of off to the side. So T of 1 is 200. R is our multiplier, and we can see it right here. It's 1/2 or 0.5, whatever way you want to write it. And then we're going to do n equals 10 first. So 200 times 1/2 to the power of 10. I see him. He wrote you a note. Divided by 5 minus 1. Come here, buddy. My calculator actually died. So if you can, will you plug that in for us so we can see what we get? I guess I could do it on my phone too. Okay. So I did it on my phone and I got 399. .609375. I just wrote out the whole thing. That's what I got. Anyone get something? If we could have rounded that to 0.61. But again, remember your order of operations. If you're typing this into your calculator at once, do the whole numerator, and then you can put it in parentheses, divided by, and then the denominator in parentheses.
What I got out of my box today.
You got a fire truck?
Yeah.
That's so cool.
The water can.
So now for S of 30, we're going to do the same thing. The only thing different is sorry, I guess my internet went out. So I'm not sure when it cut out. So again, I just typed this in. It's the same thing, except it's a 30 in the exponent. So 200 times 0.5 to the power of 30, and then minus 200 divided by 0.5 negative. So this one is approximately 399.1234567 6 nines, and then a 6. So here we can see we added 20 more terms, but this number didn't grow very much. It only went up by less than 0.4, less than 4/10. So as n gets larger, the sum gets closer to 400. And then for B, it's 16 plus 24 plus 36 plus ... all the way to 16 times 3 halves to the power of n minus 1. So T of 1 is 16, R is 3 halves, and if you want to make that a decimal to type it into your calculator a little easier, you can. And we're going to do n equals 10, and then we're going to do 30 the second time. All right, so our first term is 16 times the multiplier is 3 halves to the power of 10 minus 16, all divided by 3 halves minus 1. All right, so I got 1,813.28. I'll just round it here. This one I didn't round because I wanted you to really see what was going on. And then they also want us to find S of 30. So 16 times 3 halves to the power of 30.
What I'm eating.
Oh, yummy.
Do you wanna bite?
No, thank you.
Okay.
All right, so 16 times 1.5 to the power of 30 minus 16 divided by 0.5. All right, so this is a much larger number. So 6,136,001.9. So here, as n gets larger, the sum also increases. And in this case, by a lot, right? Here we added 20 more terms and we only went up 0.4. Here we added 20 more terms and we went up over 6 million. So here the difference is because the multiplier is less than 1 for part A. So for an infinite geometric series, so infinite means it goes on forever. The series is never ending. We have a slightly different formula. So the sum and we don't put S of n because we don't want n terms. This one goes on forever. The sum is A divided by 1 minus R. If 0 is less than or equal, or so if the absolute value of the multiplier is between 0 and 1. So here A equals the first term and R equals the multiplier. So this could also be written as T of 1 minus or over 1 minus R. That's the same thing. The book just uses A. Since we've been using T of 1, if you want to write it this way, that's fine. But again, for an infinite, goes on forever, geometric series, so we're multiplying. If the multiplier, the absolute value is between 0 and 1, we can use this formula. So for example, if we have 200 plus 100 plus 50 plus ... and if it just says ... that means it's going on forever. So here, A would be 200, or T of 1. Our multiplier is 0.5. So we're allowed to use this formula because our multiplier is between 0 and 1. So our sum is 200 divided by 1 minus 0.5. Which gives us 400. And if you notice, this is the same series from part A on 114. So here I said it was getting closer to 400, and so that series has a sum of 400. All right. Any questions on that before we move on? So again, this only works for an infinite geometric series with the multiplier between 0 and 1. And it can be negative. It'll work for a negative also. Okay. So moving on to what problems are we doing next? There's my paper. 137. So we're kind of shifting gears, and you have to remember the combinations and permutations from Math 2, which, like I said, I know some of you did at the end of the year. We're going to do some notes on those real quick to help us with this next part of the classwork. Well, I guess I should have asked you guys, Do we remember combinations and permutations? Maybe, anyone? I'm going to assume we don't, because like I said, I know it's chapter 12 in math 2, and not all math 2 teachers did it. And then even then, it was in the end of May and things were just not very organized. Yeah, so some people remember them a little bit, not really. So hopefully we've seen them, and if not, that's okay. So a permutation is order matters and you can't repeat. So it's usually written with a little n, a P, big P, capital P, and then an R, a small one. And that's n factorial divided by n minus R factorial. And so remember this factorial, this explanation mark. So for example, 5 factorial means 5 times 4 times 3 times 2 times 1. You start at the number you're at, it has to be a whole number, and you count down. So this NPR here, N means N items, and then R at a time. So just one example here of what this means, because here I said order matters and you can't repeat. So you have n items to pick from and you're picking R of them. The order that you pick them matters and you can't repeat. You can't pick something twice. So just a little example, a student body of 15 wants to elect a president, vice president, oops, that should, the secretary, and treasurer. So this example would be a permutation because, so we have 15 people and we're choosing a president, vice president, secretary, and treasurer. So we're picking 4 things, and order matters. For example, because if you'd pick the president first and then you can pick the vice president, and you can't be both. That's what it means by you can't repeat. So this problem would be 15P4, which means 15 factorial divided by 15 minus 4 factorial. So that's 15 factorial divided by 11 factorial. Yes, your calculator has a button that'll do this for you. I don't have my calculator here, but this isn't hard. If you don't have if you don't know where that button is on your calculator. So that's what 15 factorial looks like. 10 or 15 times 14 times 13 times 12 times 11 times 10 times 9 all the way to 1 divided by 11 times 10 times 9 all the way to 1. So 11s cross out, 10s cross out, 9s cross out, everything in between would cross out, and the 1s would cross out. So this would just be 15 times 14 times 13 times 12, which would be 32,760. Again, you can find this button on your calculator. The graphing calculators, it's under math and then probability. You can even type it in like this, but it's not hard to kind of write these out. And then a combination is order doesn't matter. And you can't repeat. So both of these you can't repeat. You can't choose the same thing twice. This is written as NCR, and we read that N choose R. And it's almost the same. It's N factorial divided by N minus R factorial times R factorial. So the denominator has an extra R factorial. That's an R, not an N. So example, Natalie has homework in 5 classes. She only has time to do 2 of them. So Natalie has homework in 5 classes and she only has time to do 2 of them. 2 assignments. I guess I should have written, that's okay. So it doesn't matter if what the order she does these in. She's going to complete 2 assignments. It doesn't matter if she does math and then history or history and then math, or English and science or science then English. It doesn't matter as long as she does 2 of them. So that's why this one is a combination, because it doesn't matter the order. So this is 5, choose 2. She has 5 assignments. She's choosing 2 of them. So 5 factorial over 5 minus 2 factorial times 2 factorial. That's 5 factorial divided by 3 factorial and 2 factorial. So 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. This 3, 2, 1 and this 3, 2, 1 cross out. 5 times 4 is 20 over 2 is 10. There's 10 different combinations she could choose of 2 assignments. So hopefully that looks a little bit familiar from last year. So let me open 37 or a book so we can read 137. And then also you probably remember tree diagrams, which we're going to do our tree diagram here. So 10-137, Carrie is the top batter of her softball team. Carrie has a batting average of 400, which means she gets a hit 40% of the time that she's up to bat. Carrie comes up to bat 4 times in a game. Let H represent a hit and M represent not a hit or a miss. For example, HHMM represents a game in which Carrie gets hits on her first and second times at bat and does not get hits on her third and fourth times at bat. Make a tree diagram to list all of the possible outcomes. If she has 4 at bats. So I'm just warning you, this tree diagram is going to get a little bit big. If you don't have enough space on your paper, go ahead and flip the page. So, I'm going to flip the page actually because I was getting to the bottom anyways there. All right, so the first time Carrie comes up to bat, one of 2 things could happen. She could get a hit or she could miss it. So notice I'm not starting right here because I want space to go up still, if we remember tree diagrams. And then, so this could be a hit and this could be a miss. And remember, it said she got a hit 40% of the time. So this H would be a 0.4 and this M would be a 0.6. All right, that's her first at bat. Second at bat is essentially the same thing. She could get a hit, which is 0.4, or she could miss. If she missed on her first at bat, she still has the same two options for her second at bat. So the first at bat, she could get a hit. Second at bat could be a hit or a miss. First at bat, if she gets a miss, second at bat could be hit or miss. Well, if she got 2 hits in a row, she comes up again and she could hit for 0.4 or miss for 0.6 probability. If she hit and then miss, she still comes up a third time for where she could hit and miss again. If she missed and then hit, same idea. All of these, when the branches split, only have 2 options, hit or miss. So that's what the tree diagram looks through 3 at bats. It says she gets 4 at bats. So if she got 3 hits, she can come up one more time where she's going to either hit or miss. She could either hit or miss here. Each of these you're adding a hit or miss split to. And I'm already not having enough space like I would like. All right, so it looks like that we're at the end. You should end up with 16 branches. I'm not going to write the numbers on each of these, but I am going to write out what each one is. So like this top one would be hit, 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 4 H's. This second one is H, 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 M. Here we have H, H, M, H. H, H, M, M. So go through and write out what kind of would be on the end of each of those. All right, so I will give you guys a little bit of time to finish writing all of those out. Okay. So part B says Carrie's dad buys her an ice cream cone if she gets exactly 2 hits in a game. Carrie prefers pizza over ice cream, however, and she has convinced her dad that if she gets 3 or 4 hits in a game, he can forget about ice cream. He can buy the whole team pizza instead. How many of the different possible game outcomes result in Carrie eating an ice cream cone? So she eats an ice cream cone if she gets exactly 2 hits. All right, so I'm just going to go through and kind of mark what ones have exactly 2 hits. This one, this one, this one, that one, that one, that one. So I'll just kind of say put C star. So it looks like there were 6 times that she had exactly 2 hits. And then part C says the number of ways that Carrie can get exactly 2 hits can be represented by 4 choose 2. So 4C2. And that's what the book says. I didn't make that up. And then how do the 4 and 2 relate to this situation? So here, the 4 is the number of at-bats. And the 2 is the number of hits. So here we can see that there's 16 different possible outcomes. And part D says, are all of the possible outcomes equally likely? And no. So these are not all equally likely. For example, H, 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 H. So 4 H's, that gets marked there, sorry. That's would be 0.4 times 0.4 times 0.4 times 0.4. That first going all the way up, every H is a 0.4, which is 0.0256. And then where HHMM, this first one with 2 hits and 2 misses, would be 0.4 times 0.4 times 0.6 times 0.6, which is 0.0526. So you can see she's more likely to get this with 2 hits and 2 misses than she is to get all 4 hits. All right, so E, what is the probability that Carrie earns an ice cream cone after the game? So Remember it says up here on part B, she prefers, oh yeah. So sorry, I was jumping ahead to the next part. So each of these 6 ways that she gets ice cream, it has the same probability. So let me just write that down. Each of the 6 ways she can earn an ice cream have equal probability. Oh my goodness, I can't spell today. Okay. So we said there were 6 of them total. These all have equal probability because they all have 2 H's and 2 M's. So either way, it's 0.4 times 0.4 times 0.6 times 0.6. Because order doesn't matter for multiplication. So this, like this one right here, M would be 0.6 times 0.4 times 0.4 times 0.6. That's the same thing. These all have the same probability. So the probability of ice cream here is 6. There's 6 ways that she can have this 0.4 times 0.4 times 0.6 times 0.6. So again, this is one of them, the 0.4, 0.4, 0.6, 0.6. But there's 6 times that happens. So this is equal to 0.3456, or about a 35% chance. All right. And there's one more problem we're going to do. We're going to skip part F. We're going to do 138. Okay, about 65% of the adult population worldwide is lactose intolerant, meaning they cannot digest dairy products well. 5 non-related adults are at a dinner party. What is the probability that at least 3 of the adults are lactose intolerant? Be sure to define a success and a trial in this situation. So that's just going to be how many guests and then the lactose intolerant. So, and it says they're not related to kind of not have genetics be a factor in this problem. So I'm going to use L for lactose intolerant. And every L is equal to 0.65. It told us that 65% of the people are lactose intolerant. So every L is going to be 0.65, and T will just be tolerant. They are tolerant of lactose, which every T is then 0.35. Because these have, you either are or you aren't, either 65% or you're in that 35%. So the problem says at least 3 people in this dinner. So there's 5 people. We want the probability that at least 3 of them. So we're going to break this into 3 pieces. shouldn't have even written that. That's okay. Because it says at least 3 people. So it could be 3, 4, or 5 that are lactose intolerant. So this 3 pieces is because there's 3 different options here. Okay, so I'm going to break this into 3 pieces. We could make a tree. The tree would look almost identical, except at the 5th person, it would have another set of branches here, and they would be L's and T's. So it gets kind of messy. We could also list them all. But again, the list is going to be larger than this, so it can get kind of messy and tedious. So I'm going to break this into, like I said, 3 pieces. So the first piece is going to be where 3 adults are lactose intolerant. So again, we could list the ways, but instead we're going to use a combination. This is going to be 5, choose 3. So this is 5 guests and 3 of the L's. Remember, a combination order doesn't matter. So of these 5 guests, how many ways can we have that 3 of them are lactose intolerant? So this is 5 factorial over 3 factorial times 2 factorial, which this just ends up equaling 10. And again, if you just plug this into your calculator, it'll end up being 10, which this is actually the exact same one we did in our notes almost. So what this means is there are 10 ways to have 3 lactose intolerant guests. It's a little tricky, a little weird. So again, if we listed them, we would have a list of 32 things. And in that 32, in the list of 32, of where they're all T's and L's, there would be 10 of them that have 3 L's with 2 T's. So let's see. There's 10 ways to have that. And then each one will have 3 L's and 2 T's. So LLLTT is something like 0.65 times 0.65 times 0.65. Each L, remember, is 0.65, and then the two T's are 0.35, which we know we could be lazy and write that as 0.65 to the third and 0.35 squared. So this would be 10 times 0.65 cubed times 0.35 squared. Again, there's 10 ways in our list that would happen. And then each one is 0.65 cubed and 0.35 squared. All right, so let's plug this in. So this is about 0.336. All right, so that, again, it said at least 3 adults. So we could do 3 adults are lactose intolerant, and then 4 adults L, and then the last piece over here will be 5 adults are lactose intolerant. So if we want 4 of them lactose intolerant, that would be 5 choose 4, which is 5 factorial over 4 factorial times 1 factorial. That ends up being 5. So if we listed all of the possibilities out, 5 of them would have 4 L's with 1 T. So since it's 4L, that means there's 1 T. 4 L's, 1 T is 0.65 to the 4th times 0.35 just to the first power. So 5 times 0.65 to the 4th times 0.35. This is about 0.312. And then if we want all 5 adults lactose intolerant, or we want to know that probability, that's 5 choose 5, which is 5 factorial over 5 factorial, 0 factorial. 0 factorial is just 1. There's only one way. In our list, we would only have one thing with all L's. In every L, so this would be 1 times 0.65 to the power of 5. We wouldn't have any of the 0.35s. This is about 0.116. So again, the question was, what's the probability that at least 3 guests are lactose intolerant? So if I add all of these, 0.336 plus 0.312 plus 0.116, 0.764. So that's about a 76% chance. 1 second, buddy. All right, that was it. So again, this is a little bit changing gears from what we were doing with our series. It will come into play a little bit. What, buddy?
How do we start my TV?
Turn your light switch on.
Okay.
Okay, I'll check in a minute. Okay, we'll build on this next week, where we are going to finish out chapter 10 on not till Monday mostly, and then we'll do something short on Tuesday with a review. Next week on Wednesday, you'll have your team test, and your test will be next Thursday. We probably wanted one more day, but I think it would make more sense to get it in before you take 2 weeks off and then come back and expect you to remember a bunch of this and be tested immediately. Yes, I'm expecting you to remember some of it, but not to be tested immediately. So next Thursday, just a heads up, you will have this test. Tomorrow, you will have an attendance question. Please make sure you do it by noon. It should take you a whole 30 seconds maybe. And all of these assignments are due by Monday at 10 a.m. when I see you next. Otherwise, you are free to go.